Hi again, everyone. We're going to wrap up trig with looking at chapter 7. And so in this video, we're going to do 7.1 and 7.2, which is the law of sines. And they took the law of sines and they made two different sections out of it depending on what kind of situation you have. And so this is oblique triangles. Oblique just means that it is not right. So we could have the acute angles. Remember, those are the ones that are less than 90 degrees. Or we could have the obtuse angles here. That are the angles that are between 90 and 180. So that's what we're talking about with oblique. It just means that it's not 90 degrees. It's not a right triangle. And so to do that, we're going to use a couple different rules. One is the law of sines. So to solve the law of sines, or to solve an oblique triangle, you can use either the law of sines or the law of cosines. And so what we're looking at here is these sections right here, 7.1 and 7.2. So in both of those, we're going to be using the law of sines. So there are different cases that pop up, and they're based on your congruencies from geometry. You might remember if you did a proof in geometry, you might have proved something by angle, angle, side, or angle, side, angle. Those are the type of triangles that we can solve using the law of sines, where you have two angles and one side. 7.2, we will also look at angle, side, side triangles. These don't usually pop up in high school because, for two reasons. It looks like it spells ass. But the other reason is because it's an ambiguous case. And so since it is ambiguous, you can't prove a congruency with it. But we can solve a triangle if you have two sides and one angle out beside it. And so the law of sines is given down here at the bottom. And we'll get back to the 7.3 stuff in the next video when we talk about law of cosines. Law of cosines does side, angle, side, and side, side, side. But the law of sines, whether you're solving for sides or solving for angles, you can take two different ratios, set them equal to each other, and solve for whichever one you're missing. So, for instance, the law of sines could be remember the small letters are the sides, so A, B, and C on the top of the first one. A, B, and C would be the sides. Sine A, sine B, sine C would be the sine of the angles. Or you could flip it over and put the sine A, B, and C on top and the side A, B, and C on the bottom. It doesn't really matter. In this section, in 7.1, we're typically going to be solving for the sides. So I'm going to use this version in this section. So that was supposed to say 7.1. Looks kind of like a U or something. And in the next section, 7.2, I'll probably use the other version. But it doesn't really matter which one you use. But you only need two of the ratios to set up a proportion to solve it. So we don't use all three pieces every time. We only need two of the three. So you might use A over sine A equals C over sine C. Or sine A over A is sine B over B. And you don't use all three. So keep that in mind. So here it says find the length of side A. And so side A is the right-hand side of this triangle. You have angle A being 60, angle B being 75. They don't tell you angle C, but we will need angle C because if I want to solve for side A, I'm going to need a sine A in the problem, and I have an A right here. I'm going to need a side A across from it, so we'll put the A on the top like that. And since I am looking for A being one of the sides, I have to know one of the other sides. I know this root 2 is actually C. So I'm going to use C over sine C. I don't know angle C, but I can find out angle C fairly easily because all the triangle angles have to add up to 180. Ooh, excuse me. And so, if you just do 180 minus 60 minus 75, this would be angle C. So if you did 180 minus 60 minus 75, you should get 45 degrees. So this angle at the top is 45. And so I just put the stuff in that I'm looking for and what I know. So side A is my unknown. Sine of A would be sine of 60. Side C is the square root of 2. And sine of angle C, which would be 45 degrees. Because I'm looking for the side A on the top, what I would do is I would multiply sine 60 over to the right-hand side and say that A equals the root 2 times sine of 60 degrees over sine of 45. Now, 60 and 45 are actually angles on the unit circle. So we can find an exact value for this. Sine of 60 degrees is the square root of 3 over 2. That's your y value at 60 degrees. Sine of 45 is root 2 over 2. So I could say that A is root 2 times root 3 over 2 times 2 over root 3. If you flip the fraction, oh sorry, not root 3, root 2. If you flip the fraction over on the bottom and multiply it, you'll have 2 over root 2. And then we cancel stuff off. The root 2 sitting in front cancels the root 2 on the bottom. The 2 on the top cancels the 2 on the bottom. So apparently A is the square root of 3. Now, on most every problem, we're not going to get an exact value. We just got lucky that we came up with angles that actually were on the unit circle. Most of the time, we're going to be doing these type problems in the calculator. A lot of calculator stuff. And most of the problems are going to be in degrees. So you'll want to have your calculator ready and put it in degree mode for most of these problems. So for instance, find the remaining sides. You notice that it doesn't ask you to find the remaining angle. It just says the remaining sides, but you will have to have all three angles to find all three sides. So I go ahead, if I have two angles already, I go ahead and find the third angle. I have angle A and angle B, so angle C will just be 180 minus the 37 for angle A minus the 48 for angle B. And so from there we go to the calculator. 180 minus 37 minus 48 gives me an angle of 95 degrees. And then I need to find side A and side B. So if I want to find side A to begin with, I would use A over sine A, and I know side C. So I'm going to use C over sine C. This is also why we had to go ahead and find the other missing angle, because I need it here. And so I will say that A over sine of 37 is 18 over sine 95. And just like what we did on the last one, I'll take the sine 37 on the lower left and multiply it on the right. You can also do by cross multiplying. That's basically what you're doing. And say that A equals 18 sine 37 divided by sine 95 degrees. And here, like I mentioned on the last one, you're not going to be able to do anything like this in the calculator. I'm sorry, off the unit circle. You'll have to do it in the calculator. So I'll do 18 times sine of 37. Make sure your calculator is in degree mode. Divided by sine 95. And these are all rounded to the nearest whole number. So if you round it to the nearest whole number, it would be 11. It's about 10.87 or so, but I'm going to round it off at 11 meters. And then I'll do the exact same process to find side B. I'll use A over sine A. Oh, sorry, that's the one I was just looking for. We're doing B now. Do the same process with B. Do B over sine B equals C over sine C. So I'll have B over sine 48 is 18 divided by sine 95. And multiply the sine 48 to the right hand side, and you'll get that B equals 18 times the sine of 48 degrees divided by the sine of 95. And again, you can't come up with anything like that off the unit circle, so you pull out your handy dandy calculator and do 18 times sine 48 degrees divided by sine of 95, and you'll get about 13. It's 13.43 or so, but if you're rounding it off to the nearest whole number, we'll go with about 13 meters. Okay, let's try another one. Here we have angle C is 115.5, angle A is 27.2, and side C is 76 feet. And so what we're looking for here, again, you have two angles, you're going to have to find the third one anyway, so I'm going to start with that and find angle B first. So angle B is 180 minus angle A, the 27.2, minus angle C, 115.5. So we go back to our calculator and do 180 minus 27.2 minus 115.5 gives me about 37.3 degrees. Then I just usually go in alphabetical order. So I'm going to find side A first. So I'll use A over sine A, because side A is what I'm looking for. And what do I know? Well, I know angle C and side C. So very much like the last one, I'm going to use C and sine C. And so A is what I'm looking for. Sine A would be sine of 27.2. C is 76. And sine C is 115.5. I'll move the sine 27.2 to the right hand side and say that A equals 76 times the sine of 27.2 all divided by the sine of 115.5. And then that goes to the calculator to type it in and see what we get. So 76 times the sine of 27.2 divided by the sine of 115.5. This is all rounded to one decimal place, so if you type that in the calculator to one decimal place, you're going to get about 38.5 feet. And I'll do the same thing to find side B. So I'm going to do B over sine B. That's what I'm looking for. And C is the one that I know stuff about. So I'll keep using that one. And so I'll have B over sine 37.3. And the same 76 over the sine of 115.5. So if you get this process down, usually law of sines is one of the easier things for people to grasp. The same process happens on every problem, basically. We move the sine 37.3 to the right-hand side, and we get B is 76 times sine of 37.3 degrees divided by sine of 115.5. And from there, we go back to the calculator and see what we get. 76 times the sine of 37.3 divided by the sine of 115.5. To one decimal place, that's about 51 feet. And we may mention this way back, I think in chapter 2, but notice that the biggest side should always still be across from the biggest angle. Your smallest angle is the 27.2. Your smallest side is the 38.5. So angle A, side A are the smallest angle inside. B would be next, and then C. So that's kind of a little bit of a check if you want to look at it. It's not a great check, but at least you know if you got it mixed up and you had a big angle across from a small side, that's going to be an issue. Okay, let's try this one. Here I have two angles, A and C, and I have side B. So I'm going to start by finding the missing angle B and do 180 minus the 87.2 and minus the 74.3. We go back to the calculator. 180 minus 87.2 minus 74.3 gives you 18.5. So 18.5 degrees. So I notice I don't have side A, so I'm going to work with side A first and get A over sine A. But now I know side B, so I'm going to use B and sine B as my right-hand known stuff. And so A is what I'm looking for, and I'll do sine of 87.2. B is 75.9 yards divided by sine of 18.5 degrees. And we'll move the sine of 87.2 to the other side and say that A equals 75.9 times the sine of 87.2 divided by the sine of 18.5 degrees. And then we're back to the calculator, typing it in, 75.9, oops, 0.9 off there, times the sine of 87.2 divided by the sine of 18.5. Ooh, that's a really big side. So we'll get that A is rounded to one decimal place, 238.9, and this is yards in this case, which kind of makes sense. If you notice, angle B is much smaller than angle A, and so you would imagine that side B would be much smaller than side A. So that's probably about right. And you can kind of also tell angle A and angle C are pretty close, so side A and side C should be fairly close in number as well. Let's see if that happens. So I know B and I don't know C, so I'm going to find C in this case. So C is my unknown, and I'm going to use sine C, and I'm going to use B as my known one. And so C over sine C, which was 74.3, is equal to B, which is the 75.9, over angle B, or sine of angle B, which is 18.5. So I'm going to get 75.9 times the sine of 74.3 divided by the sine of 18.5. So my guess is probably in the 200s anyway, if we type this in the calculator. 75.9 times sine of 74.3 divided by the sine of 18.5. Oh yeah, 230.3 yards. So it's actually not too much smaller than side A, only by about 8 yards. 8.5 actually. Okay, let's throw a word problem out there. You have a ship sailing due north, and at a certain point, the bearing of a lighthouse is 12.5 kilometers away, is northeast, north 38.8 degrees east. Later on, the captain notices that the lighthouse is now behind them at south 44.2 degrees east. How far away is how far did the ship travel between the 2 times the captain turned around and looked at it. So I'm going to draw a little bit of a picture here. We'll have a boat. So here's my boat. Boat on the water. We'll make it a sailboat. And this boat is traveling due north. So I'm going to make that up. So this way is north. He notices that there's a lighthouse 12.5 kilometers away that's bearing north 38.8 degrees east. So northeast would be kind of off to the right-hand side. So let's see, maybe we have a cliff like this, and then there's a lighthouse on top of the cliff, and it has a light shining on it, and this is where my bad artistic ability comes in. And so that looks more like a top hat on a stick, but whatever. So he notices that there is a lighthouse off this direction at an angle of 38.8 degrees, and that's 12.5 kilometers. Later on, he goes past the lighthouse, so I might need to make this line a little bit longer here. We're going to go past this lighthouse, and we're going to end up here where that north is. And so up here, there's the ship looking back toward the lighthouse, going this direction. And that's how we make up our triangle. When he looks back, he goes south 44.2 degrees east, so I'll end up with this angle is the 44.2. That would be looking back south and then east. What I don't know is this missing side. How far did the ship travel? So I'm going to call that X. So the first thing I got to find is my missing angle right here at the lighthouse. You always have to have the angle across from the side you're solving for. And so that missing angle would be 180 minus 44.2 minus 38.8. So we go to the calculator and type that in. 180 minus 44.2 minus 38.8. You're going to get about an angle of 97 degrees. And then I can do law of sines using the 44.2 and the 12.5. And I can say that the 12.5 over the 44. Oh, sorry, I left the sign off, didn't I? The sine of 44.2. That's what I know. What I don't know is the x and the sine 97. So I can move the sine of 97 off to the left-hand side in this case and say 12.5 times the sine of 97 divided by the sine of 44.2. That should be the distance that the ship traveled, which is x. So if I go to my calculator and type in 12.5 times the sine of 97 divided by the sine of 44.2, I get that ship traveled about 17, we'll go to one decimal, 17.8 kilometers. Before the ship captain turned around and looked back and said, hey, there it is over there. So whether it's a lighthouse or a top hat on a stick, it took about 17.8 kilometers for the ship to go by. Hopefully that makes sense. Another idea that's in this section is finding the area of a triangle. You learn along the way in several classes that the area of a triangle is 1/2 times the base times the height. That is only one area of a triangle formula. And then you ultimately can use 1/2 base times height if you actually know what the base and the height are. And a lot of triangles you don't know that. And so what we can do is use an area formula which is based on angles and just sides. So this is the area of a triangle using the law of sines would be 1/2 side B, side C, times sine of angle A. Or 1/2 AC sine B, or 1/2 AB sine C. Basically, they all say the same thing. Your area is 1/2 a side times a side times the sine of the angle between. That's what it says. Because if you draw just any generic triangle and label it with the A's and the B's and the C's, you might have A, B, C. This would be A, B, and C. So whichever one you're doing, if you pick the first one, you're using angle A with side B and C. So it's the angle between the two sides. So it's always 1/2 the two sides times the sine of the angle between them. So let's find the area of some triangles. The first one we can actually come up with exact values for, since it's a 60-degree angle. So my area would be 1/2 times the two sides, √3. Oh, sorry. Wrong side. I didn't read that hard. So you'd have to use the 1 and the 2 times the sine of 60. So this is BC sine A. In fact, the √3 that's given here, right here, we don't need that. So I get 1/2 of 1 times 2 times sine of 60 is √3 over 2. So what happens is the 2 and the 1/2 cancel. So your area is just √3 over 2. And that's BC sine A. The rest of them only give you two sides, so it won't be that hard. Notice the B and the C, angle A, or the A and the C and angle B. The two sides are different than the angle. That way the angle is between the two sides. So on the second one, I have the area is 1/2 times one side, 13.6, times the 10.1, times the sine of 42.5. Now, if it's not something I can get an exact value for, at this point, I just go to the calculator. Do 1/2 times 13.6 times 10.1 times the sine of 42.5. And I'll get about this is one decimal place on all these numbers, so one decimal place would be about 46.4 square meters of area. And it doesn't matter that the labels swap up. It's still going to be area equals 1/2 times each side, 30.4, times 28. Oops, sorry, put the decimal in the wrong spot. 28.4 times sine of 124.5. And we go back to the calculator and type in 0.5 times 30.4 times 28.4, can't read, times the sine of 124.5. And that's going to give me an area of about 355.8. This is in centimeters, so we'll end up with square centimeters. So just be careful on how you type it in. It's a lot of just typing in the calculator. Okay, let's do another word problem with that same idea with finding the area. You have a painter who's going to paint a special coating on a triangular piece of metal for a new building. Two of the sides measure 16.1, 15.2 meters. You know the angle between the two sides is 125 degrees. What's the surface area that she's going to put this painting on? And so my area would be 1/2 times the two sides. So I'll have the 16.1 and then the 15.2 times the sine of the angle between them of 125 degrees. And again, at that point, you just go to the calculator and you type it in. So 0.5 times 16.1 times 15.2 times the sine of 125 degrees. And you get about, this is rounded to 1 decimal for most of this stuff, so we'll do 1 decimal, about 100.2, and this would be in square meters, would be the area of that plate. Okay, so 7.2 is what happens if you have an ambiguous case. So what exactly does an ambiguous case mean, right? Well, an ambiguous case means that if you look in the different quadrants of the unit circle, sine will give you a positive value in quadrant 1 and in quadrant 2. And so if we have to do an inverse function to find our angle for quadrant 1 or quadrant 2, then we're going to end up with possibly 2 answers. So that's the ambiguous part. You could possibly end up with multiple triangles when you do this. So for instance, this is just kind of a short version of what could possibly happen. You could end up with 0 triangles, 1 triangle, or 2 triangles. And what will happen is you'll end up with 0 triangles if our angle that we're solving for, which would be B, on all of these things we're solving for angle B right here. So if your angle for B ends up being greater than 1, that means your side A can't reach, this side up here, can't reach far enough down to hit the base of the triangle. And if they don't connect, you don't have a triangle. So you could have no triangles. Or you have the option where sine of B is exactly 1. That will make a right triangle. You'll notice the little rectangle there. So you'll only end up with 1 triangle. Those are boring, and we're going to probably not end up with a whole lot of those. What usually happens that will take the most amount of work are these 2 options, where your sine of your angle B could be between 0 and 1. And because it's between 0 and 1, it could end up in quadrant 1 or quadrant 2. If you end up with an angle that is just right, you'll end up with 1 triangle, where side A is just long enough to hit 1 side. But if it doesn't work out like that, and you could end up with 2 triangles, we could end up where we have the situation down here, where side A could actually hit the base in 2 different spots, and that's how you'll end up with 2 different triangles. And you can see the same thing with an obtuse angle as opposed to an acute angle. That's what the top ones are all acute angles. The bottom one is an obtuse angle. So how do we actually solve them? Well, this is your ambiguous case. So we let sides A and B and angle A be given on a triangle. And it doesn't matter if it's A, B, and A, or if it's A, C, and C, or the lettering doesn't matter. But basically, we want to find a sine of an angle. So part 1, if applying the law of sines results in an equation having greater than 1, then there is no triangle and you're done, and you just quit at that step. If it's exactly equal to 1 like it is on part 2, then you only get a right triangle, and then you're done. Those 2, really quick, really easy. The third one is the issue. If you ended up with a sine value between 0 and 1, then you may have 1 triangle or you may have 2 triangles. And if you have 1 or 2, you make the assumption that that there could be 2, and you prove it wrong. And so what we do is we solve for what we call B1 by doing the inverse, and that B1 would be the answer for the first triangle. If you're on this third step here, there has to be at least 1 triangle. So B1 is either the answer or one of two answers. If it is one of two answers, then you have to go back and subtract it from 180 to get B2. Then you take B2, add it to the original angle you started with, and as long as it's less than 180, then you have a second triangle. If it's not, if it's greater than or equal to 180, then you only have one triangle. Now, this probably makes absolutely no sense unless you actually see it in the problem. So let's do a problem. Determine how many triangles there possibly are. So this isn't solving the triangle, this is just figuring out how many there are. So we have an angle of 95 degrees for A, and we have side A and side B. On 7.2, I'm going to set it up as sine of A over A and sine of B over B. Notice I have angle A, side A, and side B, so I'm looking for angle B here. So sine of A is 95 degrees. A is 50. Sine B is what I'm looking for. And B is 26. So what I would do is I would take the 26, multiply it on the left-hand side, and say 26 sine 95 all over 50 equals sine B. Then I go to the calculator, typing in 26 times the sine of 95 and divide that by 50. So I get that to be about 0.518 or so. Because that's between 0 and 1, I'm on step 3 of that stuff that we saw on the previous page. So I have to assume there are two B values. There may not be, but I have to assume it. So B1 would be to do the sine inverse of that number I just got. And if you have it still stuck in the calculator, I just do second sine of that answer, and I'll get about 31.2 degrees. This is all rounded to a whole number, so I'll just go with 31 degrees. Then, if there is a B2, it would have to be 180 minus B1. So I'll do 180 minus 31. So if you do 180 minus 31, you'll end up with 149. Then I have to take B2 and add it to angle A that I started with. This 149 added to 95. So if you add 149 to 95, you'll get 244. That is bigger than 180. Because this number right there, that 244, because it's bigger than 180, that means B2 never existed. And B1 was your only B value that you have. This gives me one triangle. And that's all it's asking for here, so the answer would be just one triangle. So let's do another one of those. Here I have side A, side B, and angle B. So I'm actually looking for angle A here. So when I do sine A over A and sine B over B, sine of A is what I'm looking for. A is 31. Sine of B is 48. And B is 26. So I'll move the 31 from the lower left to the top right and say sine of A is 31 sine 48 over 26. And at that point, you go to the calculator and see what you get. 31 times the sine of 48 divided by 26 gives me a decimal number. I get about 0.886. This means, again, I'm on step 3 of the 3 steps that I could choose from. So I have to have either 1 or 2 triangles here. So my first triangle, my B1, or sorry, since we're doing A, I guess technically we're doing A1 in this case. My A1 would be sine inverse of 0.886. So since it's still in the calculator, I'm just going to do shift sine inverse and then that same answer to get about, this is all to no decimals here, so that's about 62 degrees. So if there were 2 angle A's, I'd have to do 180 minus that angle A1 that I just came up with. And if I did 180 minus 62, I get 118 degrees. Then I have to see if it works. So then I'll take the A2 and add it to the B that I started with. The 118 plus the 48 from the original problem. So if I add 48 to 118, I get 166. That is less than 180. So if it is less than 180, this 166 is less than 180, that means both of these values are valid. This has 2 triangles. Okay, let's do this one now. Angle A is 58 degrees, and I have side A and side B, so here I'm looking for angle B again. And so my proportion will be the same as it was previously on one of the other examples. I know everything about A, so I'm going to do sine A over A, and I'm going to do sine B over B because that's what I'm looking for. And so sine of A would be 58 over A, which is 50. And sine B is what I'm looking for, divided by 61 for B. Move the 61 to the left-hand side, and so I'll get 61 sine 58 over 50 equals sine B. I go off to the calculator and type that in. 61 times sine 58 divided by 50 gives me 1.035. And at that point, you're actually on the first stipulation. If you get a value that is bigger than 1, that's all you do. You're done. There are no triangles with this given information. I like that one. Okay, this one says to do the same kind of process, except do it without a calculator. And so that means we're going to have angles that are from the unit circle. So we have 2 sides given, the 2 and the root 6, and we have an angle of 60 degrees. This is angle side side. You have an angle with 2 sides out beside it. They don't have the sides labeled, but the root 6 is side A. Side C I don't have, and this is side B. They ask us to find angle B. So I have A and A, and I have B side, but not B angle. So that's what I'll do. I will do sine of A over A and sine of B over B. Because I know everything about A. Sine A is 60, and side A is root 6. Sine B is what I'm looking for, so I can find the angle B. And side B is 2. So if I move the 2 to the left-hand side, I'll get 2 times sine 60 over the square root of 6 equals sine b. Sine of 60 is off the unit circle. It is root 3 over 2. So this is 2 times the square root of 3 over 2, and all of that's divided by root 6. And this simplifies. The 2's cancel. So I'm left with root 3 divided by root 6. Since they're both under a radical, you can simplify them. 3 goes into 6 2 times, so this is actually 1 over root 2, or root 2 over 2. Now, looking at the picture, it's probably kind of obvious that that angle is going to have to be less than 90. But let's just pretend you don't notice that. Where is sine of an angle equal to root 2 over 2 off the unit circle? Well, my first one, my B1, sine is root 2 over 2 at 45 degrees. You could actually type that in the calculator if you wanted to, but that's beside the point. Then your second angle, B2, would have to be 180 minus 45, which would be 135. Or if you looked it up on the unit circle, it's just at 135 anyway. But if you took the angle A and the B2, added them together, you would have 60 plus 135. 60 and 135 is 195, which is bigger than 180. This value being bigger than 180 says that the 135 is not there. And so the only angle for angle B would be 45 degrees. So this angle right here has to be 45 degrees. But you could probably get that from the picture if you just looked at the picture, that it had to be the smaller of the two angles. But if you don't notice that, you could do the same process and find out that angle B2 would not actually be there. Okay, let's see if we cannot find all the missing information. Or actually find all the missing angles here. Angle A is 29.7. B is 41.5 feet. A is 27.2. So what I'd be looking for first would be angle B. I have A for both the angle and the side, so that's my known information. B is what I'd be looking for. So if I plug the numbers in, I'll get sine of 29.7 over 27.2 would be sine B, which is what I'm looking for, over 41.5. Move the 41.5 to the top left, and I'll get 41.5 sine 29.7 over 27.2. Then I go to the calculator. 41.5 times the sine of 29.7 divided by 27.2. And so if you type that in the calculator, you'll get a decimal number, 0.756 or so, somewhere in that area. So since it's between 0 and 1, I'm on that third option. Could be one B value, could be two B values. So I have to assume there are two. If there is one, which I know there is one, I have to do sine inverse of that number. So I'm just going to take my calculator and go second sine, second enter, hit enter, and I'll get about 49.1 degrees. If there is a second value, for B, it would be 180 minus 49.1. So if I did 180 minus 49.1, I would get 130.9. Then I have to check it. If I added the A and the B2 together, my A is 29.7. My B2 is 130.9. If I add those together, I'll get 160.6, which is less than 180. And so because this number is 160.6, that is less than 180, then I know both of these angles have to work. And because they both work, there are two triangles. So it tells me to find all of the missing angles. So if there's a B1 and a B2, then there has to be a C1 and a C2 to go along with it. So C1 would be A, oops, sorry, left the 180 off, would be 180 minus A minus B1. So I do 180 minus 29.7 minus 49.1. And that would be C1, the angle C that would have been in the triangle with the B1. That's about 101.2. So this angle goes with B1. Then C2 would have been 180 minus A minus B2. So I'll do 180 minus 29.7 minus B2, which is 130.9. And go back to the calculator. 180 minus 29.7 minus 130.9 gives me 19.4. And that's my other C value. So notice, the A is the same in both triangles. Angle A is 29.7 all the way through. But if you have two triangles, you'll have a set of values for B, two different numbers. And then C will have two different values as well, depending on what B was. And then if you wanted to say, go a step further and say, what's side C, you would then have to do the law of sines again to come up with side C based on what value you got for the angles for C. Okay, let's do that again when we find the angles. Here I'm missing angle A. I have angle B and side A and B, but not angle A. So I'm still going to use sine of A over A and sine of B over B. But I don't know sine A. So I get sine A over 859 equals sine of B, which was 74.3, divided by side B, which is 783. Move the 859 on the lower left to the top right, and I'll end up with sine of A is 859 times the sine of 74.3 divided by 783. And we go to the calculator at that step. 859 times the sine 74.3 divided by 783 gives me an angle, or gives me a decimal, of 1.056. That becomes step number 1 of your process of that green chart earlier. Step number 1 says if you get a value bigger than 1, there's no triangles to solve for. And so there are no additional angles to solve for because there's no triangle. Then you can draw a smiley face because you're really happy that that's all I had to do on that one. Okay, this one says to solve the triangle. And so what that means is to find every single step. Solve for all the missing angles and the missing side. If you have them. So here I have angle A, but I don't have angle B to go with side B. So I'm going to do the same sine A over A equals sine B over B. So I'll have sine of 42.5 over 15.6 equals sine B, which I'm looking for, over 8.14. So I'll move the 8.14 up to the top left and go 8.14 times the sine of 42.5 degrees over 15.6. That is sine B. We go back to the calculator at that point, typing it in, and see what we get. So typing that in, I get a decimal of 0.353. And so this is our case number 1, basically. Oh, not sorry, number 3, case number 3, where we could have 1 or 2 triangles. So I'm going to assume that there are 2. So B1 would be sine inverse of that decimal number I just got. So I'll just do second sine of that answer. And I get about 20.6 if you round it off to 1 decimal place. Then, if I had a B2 value, that would be 180 minus B1. And so if I did 180 minus 20.6, I get 159.4. Oops, that's not a 4. And then you have to check, is that even possible? So if I was to take the A and add it to the B2, I would have 42.5 added to the 159.4. That's not looking too good. That gives me 201.9. Oh, sorry, I put the point in the wrong spot. 201.9, which is far bigger than 180. So because that number is bigger than 180, because you got 209, B2 does not actually exist. And since B2 doesn't actually exist, we only end up with 1 triangle. So there is only angle B, which is 20.6. Which means there is only angle C, which is 180 minus 42.5 minus the 20.6. So if I did 180 minus 42.5 minus 20.6, I get 116.9. So this is my angle B. Since there is only 1 triangle, this is my only angle C, since there is only 1 triangle. Then you have to go back and solve for side C. And I can solve for a side C, not by the Pythagorean theorem, because there are no right triangles. Pythagorean theorem only works on right triangles. And so you have to go back and do the law of sines again. And so here we're solving for a missing side. So I'm going to flip my ratios over. So I'm going to use A over sine A equals C over sine C. So my A was the 15.6 over sine of 42.5 equals C over sine 116.9. If I move that sign on the lower left to the top right, I'll get that 15.6 times the sine of 116.9 divided by the sine of 42.5. That equals C. We go back to the calculator and type some more numbers in. 15.6 times the sine of 116.9 divided by the sine of 42.5. This gives me 20.6. That's funny that it came out to be the same thing as B. But this is side C, so side C is 20.6 feet. And we solved the entire triangle. There is only one triangle here though. But if there were two, you would do this process twice because you'd have a B1 and a B2. You'd have a C1 and a C2. So you'd have to have a small side C1 and a side C2. Okay, let's try this one. Here we're starting out solving for angle A. So I'll have sine A over A and sine B over B. I don't know sine of A. I don't know the angle A. But I know side A is 2981. And sine B is 3968 over 2376. If I move the 2981 on the lower left to the top right, I will end up with sine of A is 2981 sine of 3968 divided by 2376. We go to the calculator and see what kind of decimal we get. So 2981 times the sine of 3968 divided by 2376. And so I will get that sine A comes out to 0.801-ish, somewhere in that area. So this could have an option that you have one or two answers. And so we assume there are two. So A1 would be sine inverse of that decimal number I just got. So if I do second sine of that answer, I'll end up with, rounding to two decimal places it looks like, how about 5323? So if there was an A2, it would be 180 minus A1, 5323. So if I did 180 minus 5323, I get 126.77. 126.77. Then I have to compare. If I added the B value I started with back to A2 that I just found, my B was 3968. My A2 is 126.77. This is looking pretty good. Plus 3968. We're looking at 166.45, which is less than 180, which means this is A2 and this is A1. Oh, I said I'm backwards. 5323 is A1 and there is an A2 and there are two triangles here. So we'll have to actually find lots of information here. And so if there's an A1, there has to be a C1. So C1 would be 180 minus the A1, 5323, minus the B, 3968. So we go back to the calculator, type that in. 180 minus 5323 minus 3968 gives me 8709. This is angle C1 because I know there are two triangles now. And angle C2 would be 180 minus A2, which is the 126.77 minus the 39.68. Back to the calculator. 180 minus 126.77 minus 39.68 is 1355. So since I have two different C angles, C1 and C2, I have to have two different side C's. So I'll have to do the law of sines twice at this point. And so I may not go quite into much detail here doing all the cross multiplying stuff just because of the amount of room I have left. I know B was my known stuff to begin with, so I'm going to use that on both of them. So I'm going to say sine B, oh sorry, I'm doing the sides now, so I'm going to flip it over. So I'll do B over sine B. And this will be equal to C1 over sine C1. So I'll end up with B, which was 2376 over sine 39.68 equals C1 over sine of 87.09. So C1 would be 2376 times the sine of 87.09 divided by the sine of 39.68. Back to the calculator. 2376 times sine 87.09 divided by sine of 39.68 gives me 3716. So C1 would be 37.16, and this is in meters. So there's side C1. Then I got to do it for C2. Do the same ratio. I'll have B over sine B equals C2 over sine C2. And so I'll end up with 2376 over sine of 39.68 is equal to C2 over sine 1355. So I'll have that C2 will be 23. And notice they almost are identical. The only difference is the top right-hand side, the angle is different. So I'll have sine 1355 over sine of 39.68. And then we go back to the calculator again. 2376 times sine of 1355 divided by sine of 39.68 gives me about 8.72 meters. So we'll have a triangle. There are actually two triangles. One has the given information, B, A, and B, that I started with, and uses angle A1, C1, and side C1. The other triangle uses the same info that I started with at the top, B, A, and B, but uses A2, C2, and side C2. But they're both legitimate triangles. Isn't that crazy? I think that's crazy. And so that's the end of 7.1 and 2, and that is the law of sines. So hopefully that made some sense.